So today we're going to talk to you about solving complex performance issues in .NET and .NET Core. I'm really excited to get into this topic, and I had a bit of a dry run with Matt a couple of days ago and was really astounded with the depth of knowledge that he brings to the table. So I'm really looking forward to what he's going to talk to us about today. First of all, a quick introduction. Matt, do you want to jump to that next slide? So Matt is the .NET performance expert. He specializes in application performance monitoring, and I'll let him explain a little bit about what that means and how he ended up in that niche. He loves measuring, finding, and fixing performance issues, which is something that was really obvious when we were kind of running through these slides a couple of days ago. He's an active blogger at mattwarren.org, so make sure you can go check that out. Microsoft MVP. You can find him on Twitter. And as mentioned, he is our UK-based Raygunner, working for Raygun for a little while now. Matt, do you want to talk about how you ended up at Raygun and also how you ended up kind of diving into the depths of .NET Core performance?
Sure. Yeah, thanks. I like that introduction. That's nice. I might have to frame that and record that. So I've been doing APM, application performance monitoring, for around 5 years or so now, maybe a tad longer, and I almost found my way into it by accident, but I realised it was a good fit for me because there's a few things that I found quite unique and interesting in the APM spaces. One is that you're doing tools for developers, so that's quite nice. So hopefully I know my end users quite well, which is always useful. But the other side of it is you really have to have a good appreciation of internals. So I'm never quite sure if I found this role because I liked internals or I learned to like internals because of the role. It's sort of chicken and egg, but either way, it's a good fit for me. So that's kind of how I found it there. And I've also realised along the way that you have quite a nice excuse in APM because you're writing some software that's helping other people monitor their software, and one of the golden rules is you never want to be the thing that's making their software run slower or without unduly running slow. There's always a bit of overhead for the sort of things we do, but it basically means I have an excuse to care about performance quite early on because you don't want your APM tool to be making your site worse. Really, that's the kind of one of the golden rules we sort of live by in this sort of space. So so all the things sort of fit together well for me. Really, I've got an excuse to understand things under the hood, and I've got an excuse to care about performance and ultimately help other people care about performance by the tools that I work on. So
excellent. No, that's very cool. All right, we'll dive into your slides, and I'll hand it over to you, and I'll turn off my video. But before I do, I'd like to ask everyone a quick question. This is just kind of to gauge where you are at in terms of moving over to .NET Core. So I'm going to launch this poll. It's only one question. I'm hoping everyone can see that. So have you made the switch to .NET Core? Please drop in your answers. I can see the answers coming in. I think I'll be able to share it with you guys in a second. So let's give that about 10 more seconds. We've got 40% of people with a live .NET Core app, 40% in the process, 5% are saying, mate, it's not going to happen, 22% are saying no, but it will be happening soon. We've got 85% respondents, so I think we're pretty happy with that. So let's end the poll, and I'll just share the results really quickly. Is that in line with kind of where you think the industry is at, Matt?
Yeah, I think we've .NET Core when it first came out was different, but I think we've reached a kind of, well, if not a tipping point, we're getting close to it. That it's become, certainly for new projects. I see that there's more reasons to go to .NET Core for a new project than not. Basically, it's hard to avoid it for new stuff. For rewriting old projects, that's a kind of different call. It's very different, but yeah, I think it makes a lot of sense for anything new or anything you are looking to rewrite. There's a lot of benefits to .NET Core. Part of what we're going to talk about today is some of the justification, some of the differences around performance in .NET Core and why it's worthwhile looking out for the ones that are sort of on the edge maybe or thinking about it. What benefits they might get.
Well, it sounds like 80% have either done it or are in the process, but it's probably one of those things you don't just switch over as soon as it comes out. You want to kind of make sure it's where it needs to be and you've got all your ducks in a row. So that's but that's a pretty good indication. I'll stop that. That should be gone. All right, Matt, I'll turn off my video, mate, and I'll hand it over to you. Once again, if you have any questions as Matt presents today, please drop them in the Q&A. And also, if you want any chat, drop it in the chat. I'll be monitoring that stuff, and I'll be asking the questions at the end of the show. All right, Matt, take it away, mate. I'll turn this off.
Okay. Thanks, Andre.
No worries.
So yeah, we're gonna start today. I don't mean to say this evening, because I know it's not this evening for everyone. But anyway, we're going to start today with a look at .NET Core versus .NET Framework, particularly talking about get onto things around multi-threaded, and that's around the Raygun side of things. What we can provide as a product there, and some examples and demos at the end. So let's make a start. People are, I think, from the sound of it, people are very familiar with .NET Core versus Framework and some of the differences. But I just wanted to really, in this section, is to actually focus around the performance side of things, or the changes that are around or related to performance, and why that matters. And some of this is from general things, but quite a bit of this is things that myself and my colleagues have picked up as we've ported our own tooling, so the Raygun tooling and products to .NET Core. So some of it's from experience, some of it's from general things, but it's very much with a focus on not the general changes to .NET Core and Framework, but the ones specifically around performance, and where there's generally added performance in .NET Core that you might not see in .NET Framework, and particularly as we get on later of how you can measure that and see that going on. So I wanted to start with this just as a sort of reminder, if people aren't clear about where we are at the moment with .NET Framework versus .NET Core. And this is obviously not me saying it. This is Scott Hunter, Director of Program Management at .NET. We've reached a point now where things have been different over the last few years. If you were starting with .NET Core in the 1.0 timeframe, you had a different experience of .NET Core than you have today. But it's very much clear that .NET Core is the way going forward. And certainly new features and very much performance related features as well seem to be only going in one place as well. So there's added incentives, I guess, to move over. But yeah, and this will change a little bit in the future, I guess, with .NET Core 5 or .NET 5, things working that way. But a lot of what I'm going to be showing in this talk is stuff that is only available in .NET Core, that is not being moved to .NET Framework as well. But let's start at the bottom, my favorite place, I guess, with runtime changes, and particularly around, as I said, this is all with a focus of performance. So many of you will be aware there's a new type that's popped up in .NET Core, span of T, and this doesn't intend to be a tutorial about span of T. There's a link there, and we'll make all the slides available for people if you want to follow the links, but there's a link there to a full tutorial about it. But the main reason this is come about is performance. What span of T lets you do is save on memory copies, and we actually ourselves had this. We've looked at using span in parts of our product where we're parsing lots of messages off the network and wanting to pull out parts of that. And before, without span of T, you would have had to copy memory around. That's the main problem span of T solving. But why it's particularly interesting, I think, in the .NET Core runtime is because fundamentally the same support isn't there in .NET Framework. This is one of the first features that wasn't backported to .NET Framework as it was to .NET Core. So you can use span of T in .NET Framework, but it's not as efficient, it's not as ingrained in the runtime, and it's not as ubiquitous in terms of APIs that support it. So it's part of a general trend that we're starting to see, the divergence. This is one of the first examples, and we're seeing it more and more where features are going into .NET Core runtime. And one of the parts is it's obviously that Microsoft don't want to put investment in two places, I guess that's part of it. But the other part of it is that .NET Core opens up new possibilities. It's not tied into the OS in the same way that .NET Framework was through Windows updates. So they're able to version the runtime in a different way. You can have more than one runtime installed on the machine. So anything that would have affected backwards compatibility was a big no-no or very risky in .NET Framework. .NET Core, not there. Uncaring about compatibility, but they're certainly looking to put things in the runtime that they wouldn't have done before. So span of T is a fairly fundamental change in the runtime, and it's all really focused on performance, and that performance is coming through not having to copy memory, which has a advantageous effect on the garbage collector. So that's how this ends up as performance and improvements. Another one that's maybe more clearly performance improvements is something called tiered compilation, and this again is just in .NET Core. It was available since .NET Core 2.1 as a preview, so turned off by default. I believe this is still scheduled to be turned on by default in .NET Core 3. And this helps several things, but what the graphs here show taken from the blog post from Microsoft is that it can really help on startup time. So in the world of microservices and spinning up, Azure functions and all those sorts of things where you care about startup time, tier compilation can help. And it very briefly, it breaks the old dependency that the .NET just-in-time compiler. In .NET, classically, we've had a just-in-time compiler that will compile, the JIT compiler will compile the method once. Tiered compilation gives it the opportunity to compile a method multiple times. And it does a very basic compilation the first time, which is why it helps startup time. And then later on it says, right, is this method being executed a lot? If it is, I'm going to have another go at compiling it, but this time I'm going to do the full optimizations. And I think as it comes in .NET Core 3 and in the future, we'll see more and more complex optimizations it'll do, which will help performance down the line. Because the .NET just-in-time compiler has always been slightly limited, that because it's just in time, you can't execute the method until the JIT compiler is finished. So it's had to have a bit of a trade-off. Tier compilation helps that trade-off, and down the line we may well see more optimizations done. But certainly at the moment we're getting decreased startup times, because it's able to do it quicker at the beginning. On top of that, there's pure performance improvements all the way through .NET Core. They've written the blog post every single release pretty much, and if you were to look at these, follow these links through, you'd see tens, probably hundreds altogether of performance improvements. And it's very much, I've heard it described as like a peanut butter effect, where if you get lots of small performance improvements, but across the whole runtime, base class libraries, framework, we all benefit. And lots of small improvements do start to add up. So individually, we may only be talking milliseconds or less for some of these improvements, but when they're in common bits of code that we all use day in, day out. And to give more concrete examples, here's some, I picked at random from those lists. You can look in your own time the rest of them, but we're seeing, these are the sorts of things coming in, and it's not just Microsoft engineers, because .NET Core is now open source. We're seeing the community contribute, so there's changes that make queuing and enqueuing twice as fast. To-list enumerable when you're doing link and call to-list, that can be optimized. Equality comparers for enums, and then some work done at the bottom on socket handlers. So this is what I mean about this effect. We all benefit, and it's happening across the entire ecosystem of .NET. So we're sort of working our way up. We started with the runtime. We're now talking improvements in the base class library and the framework libraries that we make use of. But probably the big one that people may be fairly familiar with is the Kestrel Web Server. So this is the Tech in Power benchmarks, and we're talking here for a very straightforward plain text application. So it's not saying that we're always going to get the 7+ million requests a second. This is like the Hello World benchmark. But the point is that now that ASP.NET Core or not .NET Core in general, I suppose, is showing up high up in the list. It wasn't before, basically. And this is really beneficial, because even if we're not in our apps that we're working on running at 7 million requests a second, at least we know that the runtime is capable of that. And so maybe it's slightly marketing, but I think it's good to know that the .NET runtime can compete in this sort of high-end space alongside C++, Rust, Java, and some of the other ones that are represented there. And the other nice effect of this is there's a lot of optimizations that went into making Kestrel faster that trickle down. So some of them are just in the Kestrel Web Server themselves, which we can use if we want to on .NET Core. But more significantly, some of those made their way back into the client libraries for HTTP or into the parsing libraries for URLs or things like that. So this is not just contained in the Kestrel Web Server where you'll get to benefit from these. And I know as well, I've seen cases where someone's justified a performance, sorting out a performance issue because it means that the Kestrel Web Server is running slower. So it's a kind of a forcing function, I guess, to make sure that performance stays high. But on to some other, maybe it's hard to, well, we'll talk about why this is performance related, but there's definitely a change in ASP.NET Core around asynchronous code, and it's become more ubiquitous. This is from the ASP.NET Core performance best practices page, and it's very clear that they're now calling out that you want to be using asynchronous code wherever possible. But more than that, the last point that's on the screen here is that actually the entire call stack is asynchronous. So it means that Kestrel Web Server and anything that's built on top of that, the MVC pipelines and all those type of things, Razor pages, are all I guess asynchronous by default is one way to think about it, and that helps performance because as it talks about in the first tasks here, we're not blocking threads, we're not tying up threads. So it means that scalability, everything in .NET generally is built on top of the thread pool, so the thread pool can be shared. It just means that it's what helps things like Kestrel to scale up. And we've definitely found this as we've been working on support in Raygun for .NET Core, is that we've had to add a whole lot of support to cope with asynchronous code, and we'll show some examples of that later. Because the part that becomes trickier is you can no longer rely on anything running in one thread. So in terms of analyzing your performance, you want something that lets you see, when your code starts running in one thread but resumes in another thread, you want to make sure you can analyze that. So that's part of what we've put into the Raygun APM tool recently. So that's around asynchronous, and that's kind of become more and more ubiquitous, and it's certainly best practice. And it's, even if we don't aware of it in our own code, it's certainly in all the code in ASP.NET Core. And you've probably seen over time recently more and more async methods appearing, or with the async suffix on the end of it, although there's some debates about whether people like that style. But anyway, it seems to be the way there is, methods async. So just to explain what we mean with the support in Raygun is that we have ability to let you visualize your code or profile it when you use the async and await keywords, which is probably the main way that most people are doing asynchronous code. We also support the tasks that this is all built on top of. So you can obviously, if you really want to, you can manually schedule tasks, task.run, task.start. Although I'd imagine most people are using async and await keywords first. We also support everything running through the thread pool, so you can queue things through the thread pool. Timers, and this is all available in .NET Core 1.x and 2.x support, and will be available in .NET Core 3 at some point after it's officially released. And just as a slight side story to give a bit of an insight into sort of the things you run into when you're working on an APM tool, if you haven't guessed it by now, to make all this work, myself and my colleagues have to become fairly knowledgeable about the internals, because we need to pull out internal implementation details of some of these things to be able to extract the information we need to be able to build up the traces that we present in our dashboard, and particularly in the terms of asynchronous code of how we stitch together things from different threads. And we need to be able to follow the flow as your code starts in one thread and maybe resumes in another, or resumes even in the same thread. We need to follow things through. And what that means is that we're often relying on internal implementation details which change in every single version. And I had the fun job of updating all our supports across every single one of those .NET Core versions, so I know them quite well by now. So it means that if someone refactors, and obviously there's a lot of refactoring going on as for performance reasons, actually. So it means we have to track these sorts of things, and it's not saying you yourself worry about, but it does mean that we have to be quite have an understanding of what goes on under the hood, I guess, is one way of thinking about it. And yeah, I know for sure that the support again for .NET Core 3 will be the same lines, that we'll have to rework some of our stuff to support the different ways this is all done, because there's no assumption by the people writing the code that this stuff changes. It's all internal details, but it's the sort of things that we have to pick out to be able to support it in our product. Aside from direct performance things, there is other things that are changing in .NET Core. If you're not aware of them, and even if you're not experiencing it, it's handy to know that now we live in a cross-platform world in .NET. If we were just .NET framework developers, we could rely on things just being on Windows, and that's fine, and that's the heritage of .NET. But in the .NET Core timeframe, it was released on Windows, and it's now initially released on Windows, on Linux, and it's now expanding to other OSs. And there's, from Raspberry Pis and other things, there's lots more different OSs and CPU architectures it can run on. And what that generally means is a couple of things. One is that you have to really test the functionality. .NET is a platform, and it attempts to abstract a lot of things away, but it also at various points relies on the underlying OS. And just to show some examples here, of there's different places, comparison of strings, when you get down to file streams and flushing buffers, that obviously works, that's very much tied into the OS. Even things like starts with and end with an index and things like that work slightly different. So there's various places the .NET Runtime calls out to the OS to provide some functionality, and that and it doesn't guarantee that it's not trying to make it behave the same everywhere or behave like it did on Windows on Linux. It's doing the thing that makes more sense to the platform. And we've definitely ourselves run into this again as we ported some of the Raygun tools across to Linux with .NET Core, and we've seen this around. I just fixed something actually the other day where it was to do with network handling, and when you spawn processes, there's a couple of places where we found that you had to do things slightly different under Linux and Windows. So some of these may be older issues and may be fixed. They are. When it's a clear bug, it will get fixed. I'm not saying that, but there is times where the behavior is just different and it's relying on the OS. And the .NET Runtime is, I've seen more cases recently where they're saying that we're relying on the underlying OS. We're not going to make it behave the same in .NET. We're going to rely on the behavior of the OS. So it's just really a caution to look out if you're getting into this cross-platform side of things. But bringing it back to performance, the other side is that you can't necessarily rely on your performance being the same. If you've tuned your .NET code, or you've tested your .NET code under Windows, it's just to encourage people that if you're looking to run your application on Linux as well, you're going to want to do performance testing on Linux. These are just some ones I've picked up with a simple search. Again, maybe these are currently all open issues. Maybe they'll be fixed at some point, but maybe sometimes it's because it's relying on underlying OS functionality that is different. So it's just something to bear in mind in the performance space, that .NET has come from Windows. Everything is very tuned to Windows for the bulk of the lifetime of .NET. Stuff will get improved in Linux over time, but we're sort of in, maybe only, I guess it's only sort of 3 years into .NET running on Linux, 3 or 4 maybe, as opposed to 15 odd years of .NET running on Windows. So it's just something to bear in mind that from performance side of things, you want to look out for this. The other side of cross-platform is the diagnostics, is again, for similar reasons. We've had .NET running on Windows for 10 plus 15 years, so all the tooling is very much tailored to that. In the new cross-platform world, some of that tooling won't come across. One of the big examples is the Purview tool. So if people have used that and familiar with that, that's a WPF application that's not going to be running on Linux. So what there's been a recent initiative to do is to make more command line tooling to try and fill this gap, and we'll show one of these tools in a moment. And so if you're familiar with anything around .NET Core, you probably use .NET Build, .NET Execute, but it's now being broadened out, and there's .NET counters for performance counters, .NET Trace to run a performance trace that you can then load up in Purview. So you can capture it on Linux and then load it up in Purview or other tools on Windows. .NET Dump for memory dump. So these are the initial ones, and I believe there's plans to expand this out. So it's nice to see that they're ensuring that there's a cross-platform experience, that tooling runs the same across the different platforms that .NET supports. That does mean, however, though, that certain tooling that we've got used to over the years may not be coming across to Linux. It's just something, again, to bear in mind, but certainly what I've seen that's coming for, they've announced it recently under this blog post here, these diagnostic improvements that are going to be there as of .NET Core 3 are really nice for working from the command line across different platforms and OSs. And Raygun as well, we're looking to support our profiler and agent on Linux. And if that's something you're interested in trying out, please let myself or Andre know through the chat, and we can put you, when that's available, we can let you know about that. But yeah, we're certainly looking to have all the things that we've got available on our products, APM products on Windows. We're looking to make those run via .NET Core and Linux as well. Just to actually show this, as opposed to live demo, I'll just show it here to show you what it looks like. But this is what you get with the .NET counters, and so this is the sort of thing you can expect, and it's quite nice because out of the box it gives you all the useful counters that you'd expect. Number of GCs per second, the size of the GC heaps. So it's a really good tool to start off with. This is available on Windows and Linux under .NET Core 3. You can there's other performance counters, so there's a whole range of performance counters. And what they did for .NET Core is made a so if you've done work in performance tracing and performance counters to some extent in .NET before, you probably would have used event tracing for Windows, ETW. And if it's not obvious from the name, that's not cross-platform, right? That's very much tied to the Windows is piggybacking off the working on top of what the OS provides. So they've made a cross-platform tooling, and it's coming out of the runtime of event traces, event pipes, and there's a whole system of it. But what it means is that the runtime can produce metrics, things like we see here, and then different, depending on the different OS, it can output it in different formats. So on Windows, it can output it to something that makes sense on Windows. On Linux, it can use the LLTNG libraries that are built into the OS. So they're definitely making an effort to make the diagnostic, as of .NET Core 3 for sure, making the diagnostics more of a level playing field across the operating systems that wasn't necessarily there. I might just pause for a second. I think I've seen some questions in the chat. It's probably a good time to, if there's any that aren't being answered by other people, I'm just trying to look through. Is there any particular ones, Andre, that haven't? Sorry, let me just try and work from the back. Concern about .NET Core, EF, and .NET Performance. .NET. Yes, that's a good point. I guess that's with the Entity Framework. I'm not going to claim to be an expert. I do know that Entity Framework Core is a very different thing from Entity Framework on .NET Framework. So yeah, there's obviously some issues there. Sorry, in ASP.NET Framework. Don't need access to context. Further is non-required. Configure await false. Don't know, sorry. Oh no, I've seen the answers. Okay, I think the ones I'm seeing are answered. So it's a bit hard.
Matt, can you hear me?
Yes.
There's one more question that says async all the things. Does that always improve performance? I know because it happens under the hood. Sometimes there can be issues where maybe actually when it goes asynchronous, it actually gives more overhead unnecessarily.
Yeah, that's good. Yeah, that's a good question. Yeah, I missed that one. Yeah. Okay, so yeah, there's there is a trade-off. So and actually we've seen if anyone's been following the core effects and other repositories, there's been things that have tried to fix it. So one part is that potentially async the machinery, if you like, the state machines and stuff, there's a bit of an overhead there for allocations. So they brought in value task, which is a task but as a struct, so they've sort of addressed that in that way. I know over time there's been more and more stuff, so mostly with async we don't get to control it, we just use the async keyword, and it's the compiler and runtime that sort of, I guess, half and half. The compiler does its job and then it relies on some of the machinery being provided by the runtime. And I know for sure that they've done things in the .NET Core 2 timeframe, maybe even .NET Core 1, to improve some of that. So I think for the async side of it, if we're just using the keywords, generally that's relying on Microsoft compiler team and the Microsoft runtime team or base class library team to improve it. In our code, well, some places we kind of have to use async if you want to play nicely with MVC and pipelines and stuff. Possibly the one place where we have more of an issue ourselves in our code is like just needlessly spinning up threads. We probably shouldn't, that can be one case where things are bad, and just parallelizing, short running tasks, just pushing a load of short running tasks into multiple threads that we spin up ourselves is generally a bad idea. The way normally we can get around this is start to queue things on the thread pool and then let the thread pool that is very intelligent about when it adds extra threads or when it reuses existing threads do that. So I guess one way is to try and stick to the high level stuff, async await, TPL, tasks, those sorts of things, and rarely, if ever, fall down to spinning up raw threads. That's generally the good advice. And that document I included earlier about performance in ASP.NET Core, the guidelines, talks a little bit about that. Okay. Is there any other questions around what I've covered so far? Any bits?
Do you see the question around EF6 and when the EDMX is growing, the performance is decreasing drastically? We have a console application, and without much of the EDMX updates, with one table on EDMX, it takes a memory of 26 megabytes, and when I add about 20 tables to EDMX, it takes around 70 megabytes. Are we using autofac IOC container?
Yeah, good question. Sorry, I'm not the framework expert. I would recommend getting hold of something like Perfy or another tool maybe to profile what's going on there. It seems like it's quite a lot of excess memory. It's always a trade-off of these sorts of things. We get a lot of nice ability with these high-level toolings that do a lot of stuff for us, but they also do a lot of things behind the scenes, and it seems like sometimes, that's I don't know. It's a trade-off we have to kind of live with sometimes. It's maybe a bit true with other parts of .NET. Nothing comes for free, right? So, sorry, no, it's a long way of saying I don't have an answer for the MC framework thing. I'd recommend posting something on the forums. What I do know is they're very good about. Part of them doing everything in the open is that they do seem very open to people. Posting things on creating issues on GitHub, and I've certainly seen people dive in and then help diagnose these performance issues, and particularly ones around memory. I've seen a few cases where people from Microsoft have helped people diagnose this. So I'd maybe put together some sort of repo or something and do that. But I don't have any more to offer that's specifically around entity framework. Sorry.
No worries. And there's also a great chat from Assad around ASP.NET Framework. When using async, we were told to use configure await false whenever we don't need access to the context to avoid waiting for the original thread the request came in on. I've heard that this is no longer required in ASP.NET Core. However, framework libraries should still use configure await false. Is that true? Looks like a good discussion there.
There's a good answer. I think it's So anyway, someone else has answered that, and that's what they're saying makes sense. So things did change, and it's one of the things that's been slightly tricky with .NET Core over the years is that stuff yeah, potentially changed over the versions, but yeah, I think I've seen a similar thing to that answer where it's continue doing it as you're doing it. But there has been a bit of a fundamental change around synchronization context that does change things somewhat. So, but I'll defer to the answer there because that seems sensible.
Excellent. All right, mate, continue.
So that's what I was going to cover on .NET Core versus framework. I guess the main sort of takeaways from my side, if I'm showing this, is that there fundamentally is a lot of performance changes going on in .NET Core, so we can get some nice benefits. And I've not seen anything that says that all of those are going back into .NET Framework. I think some are, so there is stuff that's being ported back to .NET Framework, but more fundamental things like span of T being integrated into runtime, tiered compilation, and other things. And I think as we go over time, we'll see less and less stuff going back. That quote that I started with from Scott Hunter was clear that it's sort of, the focus of .NET Framework is different. So there's a lot of benefits we can get by moving to .NET Core. Certainly the cross-platform, a lot of performance benefits. I found it a joy to work with the new project files, the recent ones that you can have nowadays with CS Proj. So there is some benefits, but performance-wise, there's certainly a lot of things going in, and I think, yeah, over time we're going to see that diverge more and more, so that we'll see the performance results and when you see those posts from Microsoft talking about things that have gone into .NET Core 3, it's across the board we're seeing performance benefits. So there's some compelling reasons to move to it. Let me talk a bit about some of the things I've been working on recently with some colleagues on the Raygun profiler, and just introduce some of the things it can do, particularly around multi-threaded. As I've talked about before, we're kind of in an asynchronous world now. It's very hard to get that far in writing your code, particularly if you're doing a web server type code to get very far without using asynchronous code. It's very much tied into the pipeline of the frameworks we build on top of. So you kind of want a solution, or you want to be able to know around code. So if people haven't seen what the Raygun dashboard looks like, so this is what you would get if you had a simple asynchronous call. And what we're doing here is in effect stitching stuff from the two threads. So above the dotted line, you see the thread where your asynchronous method call started. So you would have we'll show some code in a minute of what this can look like, but this could be a web request coming in, and then you could do an asynchronous call out to a third-party HTTP request, or it might be a database call, or whatever it is, something else going on, and then it resumes. This is actually from our internal test app. That's why it's got slightly strange names, but it shows nicely. So we're able to stitch things through in different threads, and also we're able to pick out what really matters is the total elapsed time. What we're seeing for that very short function on the top left-hand corner is that's the code that ran before the await keyword, and then the rest of it below the line is the resumption that took longer, where there's real work being done. So obviously we're being able to be stitching it all together. We're actually able to report the real time, even though it happened across two threads. The real time of this response was 1,500 milliseconds, so 1.5 seconds. In this case, we're synthetically doing it with a thread.sleep. You might have spotted at the bottom, but the same applies if it was a real web request. To look at a bit more of a complex example, I'll show you the code for this one in a second, but this is our kitchen sink case. So again, we can deal with things resuming, and what you find when you start to look into this is there's very much thread pooling and things like that going on. So you may find examples where it resumes on the same thread, it might resume on a completely different thread, it might resume on the jump to one thread and then resume on a third thread. Really, that's all kind of generally hidden away from you when you're doing this sort of code. So but we're able to stitch it all back together and present you with a view. I'm going to show in a second. I'm going to show these live in the dashboard, but I just wanted to talk through them first of all. And we're able to give you a kind of high-level overview at the top, where you can see these different threads there, and then you can delve into them. And the final part with all of this, we do actually also allow you to integrate into GitHub if you give permission to our app. So you have control over whether you want to do this. But this is significant because this is the code of the kitchen sink method I was talking about before. So it's quite handy if you're looking at these traces. You don't need to worry too much about finding the place in the code where that is. We can display that in the dashboard for you. And yeah, this is just to show the different examples, so we can deal with thread pools, queuing. What we saw in the folded up view I showed you just a second ago is the 2 continuations, but we can also do task run, the previous examples, and await, async await examples. So this is going to be, if people aren't already seeing this, is going to be more and more these more common patterns of maybe not as quite as low level as fire and forget. I don't think that's necessarily the most common pattern, but certainly having asynchronous, your requests coming in and then launching one or more tasks, and you might have 3 tasks in parallel, and you might wait for one of them to finish, or you might just have the async keyword dotted through your code and things being fired off and then resuming back on there. So this kind of side of things, and it is a test app, so ignore the fact that I use thread.wait at the bottom. Sorry, task.wait. That's not that's not good practice. But anyway, we need to test the different scenarios that people might do. But the point is, we've covered as many of these scenarios as we could think up. So I'll just switch over to show you this in a bit more of a live scenario. If I can get my right. So this is what this is the same thing, just shown live, and we just give you the ability to collapse the threads. We point out, we synthetically put in markers to show where threads continue, to indicate that this is the point where something started off. So here we see it starting in the first thread, and then it continues in the second thread, and then we have another continuation from that thread going down, and then when it's user code, we're able to I switched over to it anyway. That's the final bit of code that's executed. So again, we can, any time that it's code that's in your GitHub repository that you've linked up with the Raygun tool, we're able to pull that down and see there. So again, for thread.sleep isn't a general pattern, but it's useful for us for our testing. This is from a test app to sort of show you a bit of some of the scenarios we work our way through. And that's a kind of more complex one. This is this is the one I showed in the demo before, actually. So similar. So we have multiple threads kicking off different tasks. Sometimes they're kicked off in parallel. Sometimes there's a task and then with a continuation. So we're able to identify the different scenarios. And very roughly, what we're doing is anytime we're looking for the different places that new work can be started, I guess is one. It could be a task, it can be a thread, different things, and we're able to identify that. And then when the work's actually done in another thread, we're able to stitch it all back together and give you a nice view, so that you can make sense of it. And this helps because actually, oftentimes what your customer is seeing is this whole 4 seconds at the beginning, but really in this case it's synthetic, so we're able to show that where the time's been spent. In this case, it's spent equally between different tasks, but you're able to see actually, sometimes it might be the time spent waiting for a database call, or it might be once the database call returns, it might be the time spent rendering the view or whatever. So there's various different things that are going on, and we also build it up into system code and then your code as well to give you an idea of what's going on there. So pause there. If there's any questions, I'm trying to look if there's any more questions come up. Just looking in the chat. Yeah, is there any other?
There's a question if you can give an overview on crash reporting in terms of how the APM works with the crash reporting. Is that possible in the demo?
I don't know what I've got set up here. Sorry, I don't think I've got anything with that to show. Yeah, so to explain, people might be familiar with the Raygun error reporting tool that's been around for is the Raygun product that probably people have heard of before the APM tool, and we just integrate the two. So if you end up with an error in this, unfortunately I don't have one to show, but if you end up with an error in here, we'll be able to link to the crash reporting side of things, and the two tools talk to each other. So you'll see the errors reported in this view, and you'll be able to jump to the more detailed error reporting, crash reporting down the left-hand side, and vice versa. We've just made sure the tools talk nicely together. So if you I guess the assumption is that, you know, errors can cause performance issues, particularly a lot of them. So you can jump from seeing errors to see the traces where they're generated, and you can start with a trace and drill back to the error to see how many times that's going on. I think that covers it, unless you have anything else on that, Andre. Sorry, I don't have anything prepared for the error reporting.
That's all right. Can you set up the kind of what is defined as an error and then that shows up as an error? Is that something I saw?
Good question. So sorry. I guess so we hook into .NET exceptions. That's the very simplistic idea of what we do, the error reporting. So any .NET exceptions we have, there's various different ways in different .NET technologies to be able to know when an exception's been thrown and caught, and we hook into that, and then we sort of a higher level start to aggregate same exceptions going on, and then report them in the view here to see, you know, say that this function. But it's all based around .NET exceptions.
Cool.
Yeah.
Cool. Excellent. Well, I think that's all the questions we have in the Q&A and on the chat, and we're running 5 minutes over time, so I think we should probably wrap it up. If anyone has any questions, we'll follow up with email, and you can ask us directly over email, and we'll do our best to answer any questions you have. As Matt mentioned, you know, we've launched APM a little while ago, and we just launched it for .NET Core a few weeks ago. So it's pretty new out in the market, and if anyone wants to try it out and take it for a demo, please let us know. And I think that's it. What we'll do is we'll send out this full recording along with the slides as part of a follow-up. And yeah, I just want to thank everyone for joining us. Thank you, Matt, for sharing your wisdom with us today.